Good afternoon, folks. What I'm doing here today is showing you the solutions to problems numbers 33 through 38, excluding number 36 on page 74. It's just what I'm calling that because these questions are pretty much from the textbook. So the answer to number 33, you were given the initial and final velocities, you were asked to find the displacement. Well, just by process of elimination, C is the correct answer because in number 33, I mentioned nothing about time. Notice that in Formula A and Formula B, this is final velocity with average acceleration. This is position with average acceleration. Both these formulas involve time, and the question says nothing about time, so we're going to use the correct answer, therefore, is choice C, which we're going to use that as we solve number 34, which I'm going to show you here at this point. Get that out of the way so I don't trip over it. So V sub f squared equals V sub I squared plus 2 times A times D sub f minus D sub I. So what we're doing here at number 34 is we're looking at, we have a car initially traveling down the road at 23 meters per second. It sees a deer 210 meters in front of them, and just before the car hits the deer, the car stops. So initially it was traveling 23 meters per second. All right, traveled 210 meters. The final velocity is 0 because the car stopped just before it hits the deer. The deer stood there. Now, in solving this, 23 squared is 529. You can take 2 times 210 to get 420A. All right. Now, some people might say, hey, I can just add 529 and 420 and get 949. You cannot do that because there's no A over here. All right. So what you end up doing instead is solving for A by doing a little bit of algebra here. You bring the 529 over to the other side of the equation. So you have 0 minus 529, of course, is negative 529. You set that it's going to be equal to 420 times A, excuse me. 2 times 210 is 420. Then you go ahead and divide this out. Negative 529 divided by 420 gives you a negative 1.26 meters per second squared west. All right, negative 1.26 meters per second squared west for that answer, for number 34. Will there be something like 34 on the test? Probably not. These were meant, honestly, as challenge problems, and I think for a lot of us it was, which that's fine. I'm going to go ahead and continue showing you how we handle the rest of these. So again, there's number 34. Moving on to 35. All right, in number 35, we're talking about an airplane. It is starting from rest and accelerating east at a constant 3 meters per second squared for 30 seconds before leaving the ground. Okay, now for part A here, this is just position with average acceleration. All right, trying to figure out that displacement. All right, now some people here got 1,350 meters, or I'm sorry, they got 1,380 meters instead of 1,350. And you figure out why. They're adding this 30 in over here. I see why people do that. I get it. But here's the thing you need to consider. Order of operations. The order of operations. Parentheses, there's none. Exponents, there's just that. With 30 squared is 900. And then multiplication. You do all the multiplication first before you add. And so what a lot of people were doing, they were adding this to this over here without multiplying it first. So this just 0 times 30 is just 0. Okay? And then you multiply these three numbers together, it's 1350. 0 plus 1350 obviously is 1,350 meters. For part B, you were asked to figure out how fast was the plane going when it took off. Well, solving for velocity. We don't know the distance, and we're not trying to solve for distance or displacement, so if you look back at number 33, equation A is the one we want to use because, well, we do know time, but we don't know distance, and so that leaves us with this. The plane was starting from rest. the rate of acceleration is 3. The time is 30 seconds. 3 times 30, 90 meters per second, comma, east. All right? You know it's going east because it said that in the problems. Always remember to include that direction. 37. I had 5 times 10 to the second power. Well, some of us are familiar with scientific notation and comfortable with it, others not so much, which is fine. So 5 times 10 to the second power is 500. 10 squared is 100. 100 times 5 is 500. Another way to approach it. The acceleration is 5 meters per second squared. So we plug everything in. It's starting from rest. You have the number 2 here, the constant. The acceleration is 5. The distance is 500. There's no initial distance, so we're just going to leave that out. So 2 times 5 times 500 gives you 5,000. 2 times 5 is 10, times 500 is 5,000. Now, some of you stopped when you said, oh, my answer is 5,000. No. 5,000 meters per second. That is an extraordinary rate. To give you an idea, just real quick here, 5,000 divided by 343, which is the speed of sound, it's 14.5 times the speed of sound. No airplane is going to be able to go that fast. All right? No way. So you get this answer, take the square root of it. And on some of your assignments, I wrote that. I said, oh, you're close. Take the square root to get your final answer. So we do that. We get 70.71 meters per second north. All right, and then 38 we got here, over here in the corner. We're talking about an airplane accelerating uniformly from a rest of 5 meters per second south for 14 seconds. All right, starting from rest, the acceleration is 5, the time is 14. Using this formula, trying to figure out what the final velocity is. Remember, this formula here is just the linear acceleration formula rearranged. All right, you can do some algebra to get from this to this. Now, as far as the chapter test is concerned, you're going to see both formulas. So you can use this one. This one's a lot easier to use in this particular problem. All you got to do, take the acceleration, which you know of 5, multiplied by the time 14, and you get 70 meters per second south. All right, so again, that's just an overview of the problems there on page 74, because I was providing a lot of feedback, and I finally said, okay, I just got to go ahead and post a video. So here it is. Watch this video, learn from it, and if you have questions, email me. We can meet up tomorrow, whatever. Let me know. I'm more than happy to give you a hand.